So this is a game that I've built using Substance Designer. This is Chroma. It's a color guessing game. The reason I wanted to build this is because I get a lot of comments like on the Patreon Discord or a lot of YouTube comments where people want to learn how to use pixel processors and value processors. And now I think that those are worth learning. I think a lot of people think they should learn them, but they're like, I need to know how to use them, but they don't really know why. Like if I ask them, well, why do you want to know it? They're like, I don't know. I know I do. And it makes sense. Like they're useful to know for sure. I think in a practical sense, when I'm using them, it's usually to fix like a very specific problem, right? That I need to, a pixel processor would fix this or would make this much easier. Now, so they're in graphs I make all the time. I don't think me making a video where I just open those graphs and it's like, hey, here I needed to fix this really specific problem, so I use this and check this out. That wouldn't really be a good way to learn it. I know I wouldn't learn very well that way. So I wanted to come up with a good excuse to make something that would use a bunch of pixel processors and value processors in kind of a more simple, easier to approach way that still gets you all the info you need, or most of it, and gives you kind of something fun to build that's a bit more practical and you have the full context of what's being done. So hence Chroma, this fun game we're going to build. In today's YouTube video, we're going to build a bit of a simpler version, just because to build the full version would be, like a 6-hour YouTube video. We'll put the bigger one on Patreon. But in this version, it's still going to be the exact same. All the core functionality is here. You'll learn pixel processors, value processors, function graphs, all the different data types, how to decompose numbers, recompose them, some of the scripting you'll need to do, and the input parameters, all that fun stuff. It's all here today. So this will allow you to pick a color. And then when you're happy with your guess, and I'm not, but I'm just going through it quick, I can hit submit guess and I get my score out of 100. Pretty cool. So I could reset it, randomize it. It's one of my favorite colors. I got really lucky on the poll here. And I'm going to brick this one on purpose. And if I do really badly, oh God, a cursed number. And the screen is, I'm sure, traumatic for a lot of people. I know it is for me. But yeah, and then I could reset this, randomize it, and just go again. So this gives you a ton, like I said, of everything we need to learn today in this YouTube video. In the YouTube description, I'll include this substance graph that builds this, as well as the substance archive for this if you just want to play it. You're going to need Substance Player to play these. So if you just go to Adobe's website, search Substance Player, you'll be able to download that. It's just, that's what we're in right now, Substance Player. It's just a standalone application that will allow you to run Substance Archives. It's free, it's very lightweight, you should just go get it. We used it a lot in the animation tutorial to actually view our animations. In the Patreon version of this, we're going to be actually building the entire version, where really all that changes is it's a much better UI, and we have these difficulty modes, the logic for all these difficulty modes, and like the multiple rounds, and even like an ascension mode built in. I'm going to run through the game in a moment, but so if you want all of this extra stuff, that's on the Patreon. It's a much longer tutorial, like it's 5 or 6 hours, I think. And there's tons of other stuff on there. So if you'd like to go support me there and get like this full version with like a node by node walkthrough of it, with like the better UI, the difficulty modes, you can head over there. But like I said, in the YouTube video today, we should get a lot of the kind of core stuff you need out of the way. The Patreon will just be like way more of it and a couple more like really interesting tricks. But while we're here, let's nuts on the table. I'm going to put myself to the test on this and just play around a bit, and we'll see how I do. So I'll randomize it. I do not like this color pull. I'll say that much. I'm not good at these blue areas, really. So I'm going to try my best here. I think people will probably end up, that's not bad actually. People will be yelling at their monitor, I'm sure. People have different kind of sensitivities to different colors, I find. Some people are better at other ranges than others. This is definitely a bit more saturated. It's a lot more blue too, it's less green. So it's somewhere in here. Lots more saturated and brighter. We're like up here somewhere. It's not perfect. A bit darker. Yeah, I'm not doing great on this one. I'm bad at these versions here. But we'll submit this. I think I'm close enough. So I can submit my easy guess. Okay, so hard mode unlocked, right? The threshold right now is set to 80. So if you get over 80 percent or 80 out of 100, you unlock the next mode. So I can unlock my hard mode now, and you can see this gets trickier. And this is a more practical example of, you know, what color picking can actually be like if you're looking at reference, because you have multiple colors next to each other and it can become harder to distinguish. Luckily, this is my color. I'm a magenta guy. This shouldn't be that difficult for me. So we're going like up here somewhere, and it's quite saturated and it's quite bright actually. But those other colors are throwing me off. That's pretty good, but I need to do more blue. And I think I'm actually a bit more saturated. That's pretty good. I think I'm happy with that. So I can split my hard guess. 88.3. So it gets harder for sure. Right? I felt way more safe about that one, and it's less score than the easy mode. But I've unlocked prestige. So I can now turn on the prestige mode, and this gets really tricky. So now, if I go here, as I know where we're going. I'm lucky that this is another color that is a good pull for me. But now when I'm picking colors, the neighboring colors also swap. So now we're getting really, this is very much like the gold dress, blue dress thing. If I try to look really carefully, this is like the gold dress, blue dress, if you remember. And I'm trying to get close-ish. Just trying to gauge. I think I'm about right, but it's sometimes with prestige, I never really know for sure. This is like, I think it's a decent guess, but let's see where we go. Okay, I did pass. Cool. And I actually did better on the prestige mode. Jesus. That was a good pull for me. Those are my colors. Like teals and magentas is where I tend to be the most sensitive. But cool, 3 stars. 89 isn't bad for sure. And as you can see here, you can reset it and try the ascension modes. So if I reset and randomize, I can go to the extra challenge slider and bump the ascension difficulties up. And this basically just makes it much more sensitive to how correct you are. So I'll try one run on Ascension 2. I've never gotten 5 stars on Ascension 2, and I don't think I've ever gotten more than 2 stars. I don't think I've ever completed Ascension 3, actually, now that I think about it. But like I said, you can download this in the YouTube description if you want to try it. I'd love to see how far people get. But this is like a darker blue. There's not a lot of purple in here. And it's much more saturated. It's like over here. It's got a bit more red in it. I'm gonna actually like manually punch in the red a bit. Let's go to like 30 red. I'm still not feeling comfortable about that. Let's see this. I feel pretty close. It could probably be a bit darker. I think that's not. No, that's too dark. Maybe a bit brighter. And I think it's still more red. I think it's closer to like 17. Maybe even higher. Maybe it's like 20. Oops. Although there's my color, magenta again. I don't think this is right, but ooh, that's pretty close. Okay, let's see. 94. Holy moly. Okay, that was really close. So I'll try the hard mode. Again, this is really tough. It is blue, but it's very dark and very unsaturated. That's gonna be really tough. I think it's a bit more blue. Maybe even a bit more green. This one's really tough, but we'll go with this. Wow, okay, I improved actually. Prestige, and what we're on Ascension 2. Holy moly. Okay, another great pull for me. My god. We're in like kind of here. I have to like kind of squint. Right, so it makes you think it's darker than it is. You have to really pay attention. But let's see. Oh, okay. I did it. Holy moly. I've never done that before. I swear I didn't like set it up this way. So 91 on Ascension 2, 3 stars. That's not bad. I've gotten 4 before, but that's as high as I've ever gotten. So there's a look at how the game flow works. And like I said, if you want to learn how to make the whole flow with all the difficulty modes and the Ascension modes and all that stuff, you can go to the Patreon video or head over to Patreon and go look at it. If you want to just download the full version, like the archive at least, so you can play it, that's in the YouTube description. But with that out of the way, let's look at our YouTube version today, and let's get to the graph and actually start building this guy. So before we hop into the actual build, let's get working on practicing exposing some parameters, dealing with stuff in the function graph, talking about all the different data types. This is going to make up like the bulk of what we're doing to kind of program this game. So if you don't know how this stuff works, it'd be very tricky to understand it. If you've already done a lot of stuff exposing parameters and you're kind of familiar with the concept and all the different types of data like floats and integers and Booleans and stuff like that, you can skip this part. But if you haven't, and you haven't really touched those things much, this is probably very worth it just so that the rest of the stuff makes a lot of sense. So I have an empty graph in here, and I'm just going to make a uniform color. So this graph has no outputs, right? So I'm going to make an output here, and we'll call this color test, the name of the graph. So when you're in this graph, I can go onto any node and go down to its parameters and change stuff however I'd like it. Right, you could do the same thing if we have a blend node here and a cloud, let's say, that we're going to multiply over it. I can't multiply the cloud right over top of the color because it's grayscale, so I'm going to make a gradient map to convert the grayscale value into color, put it over top, and I'm just going to like add sub it or something. So we have all these parameters on the different nodes, right, which you're all familiar with. You can expose these. You've seen me do it in previous tutorials, especially if you've been on the Patreon and done the big walkthrough tutorials. We've done a lot of this because it's not common that I make a graph without doing it at least once. You can take any of these inputs and hit the little hamburger menu here to do a couple things with them. You can expose them as a new graph input. You can completely empty them out, or you can set them to a constant value so that they're not changeable anywhere, or at least they're not manipulatable in any other position. Like you wouldn't be able to change them. What I'm going to do here is just expose this as a new graph input. So it brings up this little window, and I can call this color 1. There's a difference between the identifier and the label here. The identifier you can think of as if you're ever trying to call that parameter from anywhere else in the graph. This is sort of like Substance's internal name for the parameter, like what it recognizes it at. The label is what we actually see on the graph. So you can have these things be very different. Usually in practice for me, these are the same name, except the identifier can't have spaces. So anytime you have a space, you'll have an underscore instead, which is totally fine. But normally, unless sometimes I have a reason to have them be different, but often I don't. So I just leave them like this. So we'll expose this. This is totally fine. I'm not going to put them in a group for now. So you'll see that this goes blue, and that means that the color is no longer changeable on this node. It's now accessible on the parent. We basically upgraded it or like promoted it to being controllable at a different level of the hierarchy, right? So you have nodes, then graphs, and then graphs that those graphs are in, and so on and so forth, right? Like a kind of a tree of hierarchy, like children attached to parents over and over. So I can't change it on this anymore. If I want to change that color, I have to double click either anywhere on the empty graph to bring up the graph's properties in the tab here, or similarly, I can double click on the graph's name in the Explorer, and that will also do that. So these are the settings on the properties window right now, not of any specific node, but of the entire graph that all these nodes are in. So I can go down here, and now under input parameters, we can see that color I exposed. And we go down here, and this will look familiar. This is just that window we just saw where we were exposing stuff. And here I can go in, change the color, and you can see the color updates in the graph. Why this is cool, like I can duplicate this. So I just hit Control D. These nodes are both exposed, and they're both linked to that same value, color 1. If I click on that little graph icon. So I can go down now, and as I change this, both nodes change. Right, they both update. So that is a cool thing. Like oftentimes you'll want two nodes to be doing the same thing, and it can be nice to have them linked together so you don't have to kind of chase your tail around making sure everything matches. So that's one use for it. But that's just an example of promoting them. What's especially cool is if we have a second graph. So we'll call this like test graph. And we open this up. We can drag other graphs into this graph. And on this one, just like on how any other node, we have settings for them. On this node we just built, which is just this graph, the color test. I'm realizing I forgot the R in there. I can change the color from outside the graph. So that's sort of an important concept to understand for the remainder of the video, is that we can expose values in a child graph so that they're controllable when that graph is put into a different graph. That's going to be really kind of a thing we do often while we're making this. The other thing we can do is talk about data types. So if you scroll down to parameters here, you'll see that this data type is a float 4. So it's 4 numbers, one after the other, right? You can think of it as HSVA. It's probably simpler to think about it as RGBA, right? So it's the red value of the color, the green value of the color, the blue value of the color, and then the alpha. So it's a vector 4, or float 4, right? So it's 4 numbers that can include decimal points. So they don't have to be whole numbers like 1, 2, 3, 4. They can be 1.0003, 1.87. They can be all sorts of different numbers between 0 and 1, or 0 and whatever, really, or negative whatever and positive whatever. They can be huge numbers, and there's 4 of them attached to each other. So it's important to understand, I'm going to go into the scale input, for example, and empty the function. So this just brings us into a graph, and the scale for this cloud doesn't have anything driving it right now. You can see down here, it says that it's asking for an integer, which makes sense because when we were changing the scale slider, it was going 0, 1, 2, 3. There weren't decimal points. So I didn't open this one for a specific reason. I could have done it to the disorder one, not scaled. It didn't really matter. But I just want to walk through the different data types. So what I might do is make in the function graph here, right? We have different assemblage of nodes here. It's all math nodes, right? So we don't have access to the same nodes we have outside of the function graphs in a normal substance graph. So let's talk about the different data types. You have a float. And what it might make sense to do is I'm actually going to, instead of doing it in there, practice it on a value processor, because this way we can just see the output number. And we're going to use a lot of these in the tutorial. So I can edit the function here. And this just, again, hops us into a graph. There's nothing in here. And you can say it's that yellow text here, as well as the yellow caution sign, are telling us, hey, there's no defined output for this value processor. So it's not doing anything, right? We have to actually build some stuff. So let's talk about the different data types. You have a float 2, a float 3, float 4. Right, these are really common. You'll use these a ton. You also have integers in the same configuration. So integer 1, integer 2, integer 3, integer 4. Right, so 1 number, 2 number, 3 number, 4 numbers. And the difference between the floats and the integers is that the floats can have decimal points. Both can go negative, both can go wherever you want, but the float does not have the ability to, or the integer rather, they just go up by whole numbers or down by whole numbers. So different things will require different pieces of data, right? Sometimes you want integers, sometimes you want floats. Generally, you can convert from one to the other. When you're doing that, you're using the casts, right? So if I cast to integer, right, I'm going to turn this 0.16 float into an integer. So I'm going to right click on this node and set it as the output. And you'll see down here, it's 0. And that's just because if you're going to turn 0.16 into an integer, it just becomes 0. But if I put it above 1, or at least 1, then the to integer will be 1. And you can do the same thing in reverse. I can cast a integer to a float. As you can see, the colors match, right? The integers have yellow nodes. The floats have these kind of pale green nodes. And I can set this as my output. And obviously, same thing here. This won't be terribly obvious because like every time we bring this up to 3 to 4, it just turns into a float 4, or like a float of a value 4. Right, so there's no decimal points involved anywhere in the process. But the important thing is you can switch between these. you have different configurations of this. So you have float 1, or just a float 2. So this is 2 separate numbers. So different things have different numbers attached to them, right? So a lot of the parameters and sliders you're moving are just a float. It's just a single number that you move around, right? You can go anywhere from negative a trillion to positive a trillion, whatever it is. A float 2 is 2 numbers appended to each other. So it's not 2 numbers added to each other, but different things will require a float 2. So a good example of a float 2 would be on a tile generator, for instance. The position random is a float 2. It's these 2 numbers attached to each other. Or if we were to go into size, like the size of these, right? If I were to expose this, it's a float 2 because there's 2 numbers. There's the X number, like where it should move in X and where it should move in Y. Right, so the float 2s you'll use for certain things, and we're going to use some of them in the tutorial as well. You have float 3, and I think people are probably more familiar with that. A float 3 is something like a color, right? If you have like RGB, right? So red, green, and blue, those 3 numbers together make your color. Everything in the red channel, everything in the green channel, everything in the blue channel. Float 4, same thing, except you have a 4th channel for alpha, so RGBA, which we'll also use occasionally. So they're just different data types. The important thing is that you can't really interact between them under most circumstances, right? Like if I try to add a float and an integer, it's not going to like it. If I try to add a float 4 and a float 1, it's not going to like it. So you need to get used to turning lower order floats into bigger order floats, or reverse, like pulling them apart. So a good example would be if we have a float 3, this is essentially a color, right? And in fact, I may do this in a uniform color node just so we can see really clearly. I need to go to the color for this node and hit empty function. It's telling me, hey, I want either a float or a float 4. So I'm going to go make a float, and I can set this as the output node. And you'll see that now our uniform color just makes black. And as we raise this, we're just making a gray, right? It was expecting a float, which we've done, or a float 4. So if it's a float, it's really just a grayscale, right? This uniform color is essentially a grayscale right now. Or really, look, it effectively is, but it's really just red, green, blue channels are all filled with 0.43, which makes them all gray because there's no difference between any of the channels. But we can have multiple floats. Well, we can do it with the float 3, or we'll do it with multiple floats. So this is really our red, green, and blue channel. And we can combine these to make a float 3. So for instance, red would be 1 red, 0 green. Can't type today. 0 green, 0 blue. We can combine these into a bigger float. So you're looking here for vector floats. So if you get a vector float 2, this will allow you to attach 2 floats to make a float 2 now. I can't set this as the output node because this graph is looking explicitly for a float 4 or a float 1. But I can get a vector float 3, or vector float 4 rather, and plug in that first vector float 2, and then I'm going to make another vector float 3 and do that for our blue and our alpha channel, which I'll set to 1. And now we've made a float 4. So we've combined these 2 to make a float 2, combined these 2 to make a second float 2, and then we've combined these 2 again to attach them together to make a float 4. And if we set this as the output, we have red, right? Because we have 1 in the red channel, 0 in the green channel, 0 in the blue, 1 in the alpha, right? And you can play with these numbers and it'll adjust the color. And this stuff will be important for what we're going to do today, right? So the important thing is you can combine these together, like attach them really, like append them together to make different data types. As well, you can do the reverse. If you have a vector, if you have a float 3, so that could be a color, it could be a position in 3D space, it can be all sorts of different things. You could use the swizzle nodes. So these allow you to plug in whatever float you want and pull out just one of the channels. So for example, right now this is a float 4. If we were to swizzle it and grab just the X channel, that would be this, right? The very first number in the float. We set this is our output. It's just going to be whatever value is red, which in this case is 1. So like I mentioned, the important thing here is just to understand that you can decompose higher floats, like float 3, float 4, into float 1s, float 2s. You can like pull them apart, and you can recompose them. You can take smaller or lesser floats, like floats, and turn them into float 2s, float 3s, float 4s. You can manipulate them back and forth. That's just a really important part of understanding how the different data types flow through the graph. And we're going to do a lot of things like that with exposing parameters, manipulating stuff in those graphs, particularly with value processors and pixel processors in the tutorial. Okay, so now that we understand how just generally a decent idea of how those data types work and how they get passed through the graphs, let's get in and actually build our game. So the first component we really need to build to just get us started here is a node that will generate for us a random color. Because in the game, we're just trying to match these randomly generated colors. So we need to build that randomly. We don't want to have to like set one and then try to match it because we already set it, so we would know what it is. So we need to have the computer build us a random one. There's a lot of ways you could do this. I'm going to pick one that I think shows off some of the stuff that I want to be kind of the core of this video. So we're going to use a pixel processor. So what this does, nothing by default, but what it's going to do is if we edit the function, it opens up a graph. We're going to build a function in here, and then the pixel processor is going to do whatever we tell it to do for every pixel of the texture. So if we say, for instance, hey, you should be, again, it's looking for a float or a float 4. So let's make a float. We'll make a float 3. Well, we'll just do them as float 1s for now. Do this. So this is our RGB and then our A. And just like in the earlier example, we're going to mix these together. So we're going to use a vector float 2 to combine these two. And then a second vector float 2 to combine these two. And then a third, or a vector float 4 to combine those. And we'll make this 1 for red, and we'll set this as the output. So this right now is sort of a roundabout way of just making a red color, right? So the pixel processor is just going pixel by pixel through the graph and doing whatever is inside of its function to that pixel, which in this case is just setting it to red. Pretty simple. But we want to generate a random color. So what we really want to do here is we want each of these numbers, because this is red, green, and blue. Alpha, we should just leave at 1. That's fine. We want these 3 numbers, so we could call these the colors. Color channels, making just a frame on them. This doesn't make it work more or less, but it's just for organization, so you can see. We really want these to be some kind of random number between 0 and 1. Because if you have a random number between 0 and 1 in each channel, then that gives us a random color, right? Because the red value will be some random number, the green value will be some random number, and so will the blue. So you have a node for this. It's just called random. And so if you hover over this, it's just going to say, this function will generate a random value between 0 and the input value. So all we really need to do is plug a 1 into this. So right now it's going to generate some value between 0 and the input value, which is X, which in the case is 1. So if we switch these out, we just get a bunch of noise, right? And we're going to go do that again here, like this, and then do it one more time. And right now, we just have this big field of random values. Each pixel is some random color, right? Between 0 and 1 in red, 0 and 1 in green, 0, 1 in blue is basically it. So this works well. The only issue is obviously this is giving us just like basically a white noise, or well, not a white noise, a color noise, where each value is just a whole bunch of colors, right? We really only want to grab one of them. So to make that work, what we need to do is sample this pixel processor and grab just a single pixel. So I'm going to grab a pixel processor, a second one, and plug it in. Go to the edit function. And what we're going to do in this one is ask it to sample a color coming from that previous pixel processor. So the way you do that is we need to sample the UV space here. So the way you do that is actually you use one of the system variables. If you've done stuff in, Unreal or any kind of shading, visual scripting shading program where you've, worked with UV coordinates or texture coordinates, this is the exact same thing. We actually need a system variable for this. So what that means is if we haven't used a get node yet, but these get nodes grab some data type from somewhere else in the graph. So I want to get a float 2 in this case because we want a position. And in fact, we don't necessarily need to use a get here. What we can do is just make a vector or a float 2 like this. And you can think about this as the X position and the Y position of a pixel. Right? So your texture sheet has two dimensions, right? The horizontal dimension and the vertical dimension. So the U and the V, it's the same thing as saying X and Y. Up and down is V or Y. Left and right is X or U, if you're thinking about UVs. So we just want to sample some position on this. If we sampled 0, 0, it would sample right up here because it's 0 along horizontal and 0 vertical. So we would be able to just grab whatever value is there. So we can go to edit this function. And what we're going to do is, it really doesn't matter what number we set these on. We're just sampling a single point of the input texture. Now, in order to sample that input texture, we plugged it into image input 0. So you have to go to edit here. We have to go to sample color. And we want to sample image input 0, which is where we plugged in our random color noise. So I'm just going to right click on this and set it as the output. You can see it did grab that top left pixel, which works great. And now these two paired together does give us a random color. Because if I seed this pixel processor, all the values in the white, I keep saying white noise because it looks like one, but all the values in this color noise switch. And because we're just sampling the 0, 0 position, we're just going to get this color, whatever it is. So if we seed this whole graph, we're just generating some random color, which is pretty cool. So one thing we probably want to change too is I would like it so that you can't get a black color, which could happen to be very rare, right? To have like a super, super dark value show up here, like because you would need to have a really low number in red, green, and blue, which is pretty hard to do. You have to roll like 3 100-sided die and get like a 0 on all 3 of them. But if we want to be extra safe, we could set it so that you can't ever get black here. To do that, we could go into the pixel processor. And right now we're generating some number between 0 and 1. But what if we just added a bit to this so that it can never actually be fully 0? So if we add here, we can actually add, we could do it channel by channel. We could also just do it to, well, we should do it channel by channel. So I'm going to add some small number so that this can never be black. So like, see if as I raise this number, the texture's gonna get much more red, right? Because I'm setting like a minimum value in the red channel. So it makes them a lot more red, essentially. I'm gonna add a very slight value here. It's very small. 0.02 is probably fine. This is just gonna make it so it can never be black. Now, the issue is if this is a random number between 0 and 1. So let's say it is 1, and then we add 0.02. Now it's actually going above 1. So we probably don't want it to go above 1. So you can use a saturate. And it's a clamp, really, that just sets a floor of 0 and a ceiling of 1. So what that means is that if the number in this node happens to go above 1, this will make it just go back to 1. It sets like a hard cap on it. So if I just put this chain, I can hit Control D to duplicate it. This will just ensure, just as a safety precaution, that we can never generate black from this random color graph. We need an output for this graph, so we'll make an output node like this. And then we'll call this graph like random color generator. And we're going to make a new graph. And in here, I'll pull the random color generator in. And you can see as we seed this, we just get random colors. Works really easy. Caught, continuity error. Where did the glasses come from? I need them to see, especially for this next part, because I have to really concentrate. So seeing is, if you need to see, glasses are really, really good. We have a random color. The thing we should work on next is how to generate that node that will compare two colors and give us a score based on how well we do. So we're going to build a very simple version. Like looking at this whole graph or like looking at the completed game, it seems like it could seem intimidating or kind of complicated, but when you're going about building it, and when I did build it the first time, I made it really simple. The UI was like non-existent, right? Like what we're kind of going to be doing today, at least. And I built it little piece by piece, right? How do I generate a random color? How do I compare the two? And then you just slowly add all these things together, keeping it really simple and adding complication as you go, just as if you were making a texture. Same kind of principle. So let's make two colors here, and I'm going to make this one just called for now, put it in a frame and call it like target, like assuming that this is the color that the game wants us to make. And I'll make another uniform color, and we'll say that this is the guess. So right now, they could not be more different, these two colors. So really, if we're going to get a score out of 100 for how well you did guessing the color, they should get a 0, right? So we know that. If we plug these two into a node that does the comparison, we should get 0, because this is the furthest apart they could possibly be, right? Every channel of the white color is 1, and every channel of the black color is 0. They can't be more different than that. So we need a pixel processor here to do that comparison, like this. And since these are just a big, huge texture that's all one color, we could do the same thing we did with the random color, where we just need to sample a single point on that texture. So we need a float 2 to give it a position. I'm going to make it sample the exact middle, which would be 0.5 horizontally and 0.5 vertically. The reason I'm picking the middle is I just want to keep it away from the edges in case we downscale these textures later and we get like mipping on the edges of the texture if it gets really small and the color kind of alters a bit. So I'm just going to make it pick the exact middle value. It didn't have to be the exact middle. It could have been like 0.8 and 0.8 or what. It doesn't really matter. But this is just shorthand. I want to sample that exact middle of the texture. So we need 2 sample colors. We need to sample image input 0. And we need to sample image input 1. Cool. So that's simple enough. And we can look through. I can set this as my output, right? This would just sample input 0, which is our white color, or sample input 1, which is our black color, right? There we go, right? So black or white. And now we just need to compare these and see how different they are. There's certain ways you could do this. We're going to build it the way I'd prefer here, just because I think it matches up better with the kind of topics of the video. But we can get into some weirder ways you could do this as well, potentially. So what I'm going to do is compare these channel by channel and say, hey, how different is the X value? How different is the Y value? How different is the Z value? With the R, G, and B, and then create an average from those differences. So I can get a swizzle float here because I need to pull out just that red channel, which is the X. I'm going to pull out just the green channel, which is the Y, and just the blue channel, which is the Z. And we're going to do that for both color samples, like this. Cool. And then all I'm going to do is find the difference between the blue channel of the first input and the red channel of the first input and the red channel of the second input. So whenever you're finding a difference, you're really just looking for a subtraction if you're comparing it just two numbers like this, two simple numbers. So I'm just going to subtract, the order doesn't really matter, but we'll grab the two X's and subtract them to get a difference between them. We're going to do the same thing with the Y's, which is the green channel. Like this. And we'll do the same thing with the Z's. We're accidentally creating like a spirograph here. Like this. So we've computed a difference between each of these channels. And now I'm going to add all those kind of cumulative differences together in order to come up with like a single number that's representative of the drift between them all. So I'm going to add the difference between the red channels, the difference between the green channels. And then I'm going to also add the difference between the red and green and the blue. And set this as my output. So this number will be very high right now. If we actually want to see this number, right, we can't actually see the number. We can only see the color that is representative of that number. If we want to see the number that's there, we need a value processor. So we're going to plug the pixel processor into a value processor. So this is, a lot like a pixel processor, except you're working with, you're working with numbers in both of them. But in this one, you can actually like output numbers, right? Like this number actually just displays whatever value. But we want to sample this and grab the color value from it, what number it is. So we're going to go to our value processor, go to edit function, and it's sort of similar. We just need a float 2 to grab a position somewhere on that input texture. And again, I'll just grab the exact middle just for consistency's sake. And we'll go to sample color. Well, in this case, really just sample gray, because I'm just switching the pixel processor to gray because we're only putting out a single number from here, right? It's not a color. So we may as well just do that and sample a gray input. And again, we're sampling image input 0. It's the only one we can sample in this case, but that is whatever we've plugged in to the value processor's image input 0 slot. So we go to here, we set this at 0, and this pulls that value. So a couple things. If we walk through this, if we go to our X value from our, let's just look at only the difference. I'm going to set this as our output. I'm only going to look at the difference between the two red channels, right? The node goes orange. As a reminder, the node goes orange when it's the output, right? It's the final node. So I'm going to look at the difference between these two only for a second. And it's 1. And that's because if we look at the difference in the red value, this is 1, this is 0. The difference between them is 1, which makes sense, right? And then we're sampling that color, which is 1, and there we go. Same thing if I were to sample the green channels, they would be the same as well, because they still have a difference of 1, right? Because every channel is the same here, and we expect if we were to sample just the blue, that we would also get 1. Now, the issue is, why is it then so this is 1, this is 1, this is 1. If we're adding 1 and 1 together here, we should be getting 2. And then if we add 1 to 2 here, we should get 3. So why are we still only seeing 1? And that's just because the colors that are being output by this pixel processor right now can't be higher than 1. The reason for that is because on this pixel processor, its output format, you can also see it here, is just linear 8, right? So 8-bit color information. So that's just 255 steps. We actually can't have a value above 1 or below 0 here. We talked about this a bit in I did a video on going above and below 1 and 0. This just needs to be a higher bit depth. 8-bit won't cut it. So if you go to this pixel processor, you need to set its output format here to absolute. And it doesn't have to be absolute, but in this case we do. And here we have to pick one of these F numbers, the floating points. These are the high precision HDR ranges that will let that number go above 1 or below 0. I'm just going to pick 32-bit. It's a bit more expensive, but the nodes are really cheap. This pixel processor is really, really cheap, so that's fine. But you'll see now we can get 3. Because the white color that can come out of this is no longer capped at 1. Visually, it can't show us white that's whiter than white, right? But that white value is at 3 right now. So we need this to be able to get a more complete comparison of what's going on here. So that works decently. We get some value right now between 0 and 3, the more different the colors are. So if the colors are both the same, meaning I switch this to be also white, we should get 0 because there's no difference between them. And as I make them different, that number increases all the way up to 3. So right now, 3 means that they are the most different. 0 means that they're the least different. And you can see, if I set this to black and I make the top color be red, right? So it's a difference of 1, right? So they're kind of like 33% the same, or they're 66% the same, which is 2, or they're 100% the same, which is 3, right? So 3 is the most, 0 is the least. That feels weird, right? We would rather this value be, some number between like 0 and 100, for example, right? So what we could do here is we know that this number is somewhere between 0 and 3. But if we divide it by 3, it'll be some number between 0 and 1. Because if you divide, watch this, if we divide this number by 3, now when we look at our value processor, instead of where it was 3, because we're dividing it by 3, it's now 1. And now the colors are some value difference between 0 and 1 instead of 0 and 3. So if we have black, we have white. Let's do black and then set it to red. They're 33% the same because one channel is identical, right? They're both, or two channels are identical. Green and blue are both 0. One is as different as it can be. Like the red channel is 1 here and 0 here. So they're as different as they can be in one of the 3 channels, which should give us a 33% score, right? Now, if we want that number to be able to be above, like 33 feels kind of weird. So it also feels odd that right now, the more correct we are, or the least correct we are, the more different these colors are, the higher our score. We sort of want the reverse to happen. So in order to do that, first of all, I don't really think we want to deal with these kind of decimal points, right? We want to score out of 100. So you really just need to multiply this number by 100. So we go into our pixel processor, and at the end, we just multiply this by 100. Like this. Now, we're getting a score out of 100 at least. Right, which feels kind of, in our final game, you saw I was getting a score out of 100, so this makes more sense. But again, right now, the more different they are, the higher the score. So the simplest thing to do here is just kind of reverse this, really. So we'll go in here and subtract whatever we get from 100. Which kind of, in effect, it sort of inverts it. Right, so now if they're super different, we get a 0. And if they're very similar, we get 100. Now, there's something else going on here we probably want to address. And that's that you can have like some red color and a green color and still get a you get a score actually over 100 right now. So we need to fix this. Part of what the issue is here is our color ranges only go between 0 and 1. This would be much better if we have them go from -1 to 1. So an even better way of thinking about this really is that because we're subtracting, the order that they get subtracted in matters, because this number can become either positive or negative. So as an example, let's just say the red channel was 1, right? In the first color. And the red channel in the second color was 0, right? And let's say down here, well, let's just do this first. So if we subtract 0 from 1, we have 1, right? Which means that's saying, hey, these are very different. And then if we say the same thing happens over here, right? Both channels here are the same, but in reverse. So in this case, of our color, our green channel, the first one is 0, the second one is 1. If we subtract 1 from 0, we get -1, right? And if we add +1 and -1, we get 0. So we know a low number. The problem is we can be in a situation where the colors are actually quite similar, but they get red is very different, or vice versa, right? So with the white black example, it's fairly simple, but even switching the order of these gives us a 200, right? So the order matters, and it's because of that subtraction, right? Because the order in which they subtract from each other makes a big difference. The way we can fix this is after the subtractions, we'll use a node called absolute. And what that will do is keep it very consistent. So if after this, I use an absolute, what this does is it returns the absolute value of the input, which is to say, if it's negative, it'll just become positive. So if you put -0.5 into this, it'll become 0.5. Put -1 into this, it'll become +1. So this will allow us to keep a very consistent result. Because if we have 1 and we subtract it from 0, right? Or if we subtract 0 from 1, we get 1. If instead we subtracted 0 from 1, I guess think about it this way, right? If we subtract 0 from 1, we get 1. If we subtract 1 from 0, we get -1. Which are very different, right? They have a difference of 2 between them. But if we plug both those numbers into the absolute, that -1 will become 1. So it sort of means that it won't matter what order these come in at. We will still have the same difference between them. So those absolute nodes need to go after every subtraction, and that will fix that problem for us and make them feel not only we won't have that situation where the order matters, but it's also going to create scores that feel a lot more intuitive, right? So right now, the order no longer matters, and the color differences feel a lot more intuitive now, right? So as we make this purple more green, we should get slowly a higher score until we match it. So this feels pretty good. And this is simple. It just gives us a really nice way of comparing those two colors. So we're going to use this node in our main kind of game graph, and we're going to need it a couple times to compare potentially different colors. So we should make this graph, we'll call it like color compare. And we're going to make a new graph here called like game graph that we're going to be pulling in a random color generator and our color compare. Now our color compare, we don't need any of the outputs that we got by default, but we will need an output grayscale to be able to output this. We need another output for the value. We probably won't need this necessarily, but we'll just call this color difference. And we'll call this score. Just so that we have names and labels for these outputs. Because maybe we need to sample this later in the graph. And then we need inputs for these, because right now all this node can do is compare the two colors that are inside of it, which is not very helpful. So what I'm going to do is go into here. I'm also going to rearrange the outputs down here so that the score comes first before the color difference, like that. We need to make inputs to this graph to be able to plug in colors. So we'll make an input color, and we'll call this one random color, because this is where we'll plug in that random color node. And we're going to make another output, or input rather, and we'll call this color guess. Like that. We'll just swap these. And we'll keep these for debugging if we want to later. Right? If something is wrong, we can come back in and actually plug in some colors just to check. Which is always nice to have. We're not going to plug them into anything, but we'll call this debug. Cool. Now if we hop into our game graph, we have a nice little node here that we can plug in a random color and a second color and get the difference between them. So even just this really is our game for the most part, right? I'm catching myself accidentally trying to play it. Right, it's a bit less yellow, a bit less saturated, a bit brighter. So even this is just the game, but now we need to actually go and like turn this into the playable thing in Substance Player. So let's get setting that game up. We're going to need to start getting Substance Player involved here. Like I said in the intro, you're going to need this to be able to display the Substance archive we export. So here's Player. You can download it from the Adobe site. It's free. It's just kind of a standalone application. So we will need to expose, or rather, we will need to send this graph. We don't need a, we're only going to need a single output here because it's just the color. We will need to send this entire graph off to Substance Player so that we can play it in there. But first we need to give ourselves like a bit of a user interface, because right now, if we put this into Player, nothing happens, right? So let's just make a simple UI. Again, in the Patreon video, I'll build the much more complicated UI, as well as, like I mentioned, all the difficulty modes. Because if I were to do that all in YouTube video, it would just take forever. This would be like a 6-hour, YouTube video. So I just want to go through setting up kind of the basics. So let's just make kind of a simple gray background. And what we want to do is be able to display to people both these colors, the color they're picking and the color they need to target. So I'm going to make a tile generator color, and we're just going to make 2 color swatches. I don't like that they're so much like longer than they are tall. But if you go and switch the size mode, we have a whole video on tile generators and tile samplers where we talk about the difference between all different size ones. I think there's a short about it too. But for simplicity's sake here, we want to do the keep ratio so that these stay perfectly square no matter how many of them we have, right? So I don't need to like fight them. I just want them to be these two color samples. So do this. Cool. So we're going to plug the color that we want to guess into pattern input 1 and set our patterned image input. And then we need a second input And that would be where our guess goes. Right, so to make that little node there, by the way, while I was dragging the noodle out, I just pressed Alt. And that's just so I can keep it out of the way. It just makes it a bit tidier. So now we can see the two colors, right? As I change my guess color, it updates. So part of the issue with this is depending on, we're going to want to seed this graph to be able to get random colors in the Substance Player version. But right now, if this tile generator seeds, it could swap the order of these. They can actually both be the guess. They can both be the target. The guess can be in the wrong spot, et cetera, et cetera. So we need to make sure that the guess is always on the right side, or at least always on the same side. The side you pick is whatever you want, right? And that the color you are trying to target is always on the other side. So we can go down to the way the patterns are distributed, the pattern input distribution, and set that to by pattern number. So this will just mean that input 1 will always go in the 1 slot, and input 2 will always go in the 2 slot, no matter how many times we see this graph, the tile generator, right? So that just keeps that consistent. Also, I'm going to set the background color of this tile generator to 0 alpha. And that way we can just blend it over top of our background really simply. Like this. The reason I was picking middle gray, and I have a slight gradient in the full version of Chroma, but I don't want the colors in the background to distract you, at least on the easy mode, from the colors you're seeing, right? But this is like a fairly simple UI that kind of gets us able to view stuff in Substance Player, right? Now, we do want to be able to have this guess exposed to the archive into Substance Player so that people are able to make that guess in Substance Player. So just like we were doing in the intro, we need to expose this color so that's controllable in Substance Player. So we right click on this and we go to expose new graph input, and we can call this color guess. And we'll make its label the same. Color guess is fine. And we'll put it in a group called guess. And now we can actually start getting this into player. One thing we should do first is we don't want these two nodes, the random color generator or the color compare, to be seeable in player. So for instance, right now, if I save, I need to publish a substance archive file to get this into player. So I'm going to do that. We're going to pick a folder for it, and we'll call this Chroma YouTube, because that's we're making the YouTube version. So we'll compile this, and then in Substance Player, we can open it, Chroma YouTube, and there we go. Right, we have our random color, and you can see we have access to all of the other graphs, right? The game graph, the guess graph, or sorry, the random color generator, the color compare node. We don't really want to see the stuff for the color compare or for the random color generator. We really only want to see the parameters that have to do with the actual game graph, right? So, and I also don't want to be able to change the size of the game graph. I want to set it so that it's always 1K. So I'm going to go to our game graph here and set the output size to be always absolute 1K. So that's always just 1K. Also, if you scroll down here, you'll see exposed in Substance Archive, which, yes, we want this one to be exposed, but we don't want the other ones to. So I'm going to turn this off in both the color compare and the random color generator. And now when we republish this, and I go into player and reload it using this little refresh button up here, it's 1K by default, and we don't see the other graphs or the size, right? So it just creates less button bloat, less stuff for people to, mess around with. We're going to do a lot of, especially in the Patreon video, we do a lot of like hiding parameters so that people can't cheat as best as we can, right? And try to make we have to like be able to hide and show different parameters at different times. So here now we just have the guess, and sure enough, you can go here and try to pick the comparison, which is nice. Really simple, right? Very, very simple. No fancy UI, but we have the basic functionality in, right? Which is really important if you're trying to make something like this, like I mentioned earlier. This stuff is complicated, and it seems like it is. But if you build it and kind of prototype it in these like really simple ways that are really pared down, you have a much better shot of like fully understanding it, right? Just like slowly building it together, slowly getting more complicated. So for one thing, we'd like to show people the score. We have the score here. Now, to get this displayed is actually kind of complicated. We can't really like plug this number over top of our, we can't like put this over top, right? It's a value. It's not an image at all. Right? So the process of transforming this, like we can't edge detect this to make it a bigger font. Like it's not a color information or grayscale information. It's just a number. So that's actually fairly complicated. It's hard to do. Now I got some help building a node called a value render that will take this value and render it as an actual bitmap. And I've loaded in a specific font in this one. So I'm not going to go through how you build this node. It would take a really long time. It would take, maybe like 2/3 of the whole video. I'll include it with the person who built it was has been nice enough to let me include it. Maybe one day maybe we'll do it soon. We'll make a video where we just make this thing because there's some fun stuff in there for sure. So we'll do that video at some point. But for now, I'll just include this in the description so you can get this and have it work properly. So this just makes a number, or it doesn't make a number. It takes our number and renders it out. And we can choose to make it bigger. You can change the font too. I'll include in the substance graph how you can go about changing the font. But for now, it's just the arcade font, which I was using. So you can make the texture bigger here, right? Make it as big as you want. And you can change the position, or you can just drag it around using the handle. And you can choose how many decimal points you want. So I think for mine, I just did 1. I didn't see with the score. It's nice to see that you got halfway between 99 and 100, but it doesn't really matter if you were like 99.9999. Like it's up to you, but I think 1 is fine. So we take 2 decimal points, and I'm going to put these. We'll take a gradient map to make it into color information and put it right over top of, we'll put it like right at the bottom here. So this is the score you got. We can scale it down a bit if we want. Cool. We also want to make a little label for score. So we'll call this score. Just made a text node. The font I was using, I downloaded. It's a free, royalty-free font called, it is called Karmatic Arcade. So I just downloaded this off of the internet. It's free, like royalty-free font. And then we need to move this into space as well. So we may as well, we'll move this down. We're kind of making a UI section here, really. So take this and add it as well. Like that. Set the blend mode to add, just so we get the white value on top. I'm going to scale down the font and just put it above our score. Cool. Makes sense. So I'm going to save this graph. I just hit Control S to save it, and then I'll republish it. And we'll open up in Player. And now, a bit more interesting, because we can go in now and actually change the color. And you can see our score updates the closer we get, which is really cool. Now, part of the issue with this, right, is someone can just now use this to go, okay, well, I'm just going to keep going, and they can use it as a guide, really know if they're like hot or cold, right, and get a really high score just by kind of eyeballing it and trying to get it into the right spot. which we don't want. We would like a system where, like I did on the intro, where you pick a color without seeing your score, and then you hit a button that submits the score, and then it shows you the score, right? That would be a lot better. So that's fairly easy to do too. What we need to do is we need to make a new data type for the graph. So I'm double clicking anywhere in the graph, and I'm going to add a parameter. And what we're looking for this time is on the type. We've talked about floats and integers. What we want this time is a Boolean. So this is just an on or off switch, right? It's either true or false. And we'll call this submit easy guesses, or submit easy. Well, I'm thinking about the difficulty modes. So we'll just call the submit guess for now. And we'll put this in the same folder as the color guess, right? So you can see the group name is guess for both. So the parameters have guess and then the slash and then the actual name. And we'll set the default to be false because we don't want it to submit by default. So this doesn't do anything yet, right? This doesn't submit anything. But we want to make it so that once people are happy with the color they've picked, they can submit it, and then this score will become visible. Right now it's off, or right now it's on, but we want this off until they hit submit guess, right? So I'm going to go into here, and this time for the opacity slider on this blend mode, I'm going to set it to empty function, right? So it's not defined at all. And I'm going to get, so we haven't done this yet, but this gets a parameter from somewhere else, right? So if we were to go like get float 4, you would see that that color guess we specified earlier is like, we can grab it and bring it in here. But more importantly right now, we can go to get Boolean and grab that submit guess that we built, right? And basically, we want to make it so that if the submit guess Boolean is on true, that this opacity value for this blend is on 1, so that the score does show up. And if the submit guess Boolean is false, it should be 0, so that it doesn't show up, right? Because we're just using a add blend mode. On 0, it shouldn't add at all, so it won't show up. On 1, it'll add at full strength, so it will show up. So what we need to do is make an if. So this will allow you to set a condition. So you can see these are both white nodes. They're the same data type, Booleans. So this is just saying, hey, if this is true, do whatever's plugged into if. If this is false, do whatever's plugged into else, right? So if true, do this. If else, do this. So if it is true, if they've hit the submit guess button, we want to set this to 1. And if they haven't hit it, we want to set this to not 10. We want to set this to 0. And we'll set this as our output. So you see it disappeared. And the reason it disappeared is because by default, our submit guess Boolean is false. But you can see I can turn it on and off now. So when the user goes in and they hit, I'm ready to submit my guess, their score will show up. So if we save this, so again, hitting just Control S as a hotkey to just save the graph, and then republish this. We go into player and we re-import this. Now you can see we can't see that final score. I'm realizing now that I am like just totally covering this. So I'm going to move myself slightly. We'll put myself over here. Where are we? Where's a good spot for me to be right now, actually? We'll put me up top. Ooh, it feels weird being up top. I'm not used to this. Yikes. All right, well, that's fine for now. Apologies. I wasn't covering anything interesting earlier, but now it'll be better if I'm over here. Man, it feels weird being up here. We'll have to get used to this. So now we can pick our color, and we aren't able to use that kind of score here as a guide, right? We're not able to try to like weasel around and find the right value, which feels bad here, right? Don't like that. But when we think we're ready, we can hit submit guess and we get our score. Now, something we should also add is right now, after you submit your guess, you could go into this and start doing it again to try to get a better score, which doesn't, it's kind of cheaty. So instead, what we're going to do is I'm going to just move myself down every time we're not in player there. It's probably a better place for me to be, but we'll see. I'm probably better here. No, because I might cover nodes. Anyway, we'll just see how it goes. I'm very used to, I like being down here. Down here is good. So now we don't like that people are able to change, like to be able to submit their guess and then alter the color. So what we really want to do is that once the submit guess is true, we should hide this color guesser so that people can't access it. It's the best we can do right now. So we'll hop back into Designer. That's probably a good idea. Let's just do this. Oh, we're so smart. So smart. Wow, look at this. Streamer mode. Wow, wow, wow. Whoa, whoa, whoa. Get the best of both worlds here. Cool. We just need to rearrange that. We're clever. There we go. Okay. So we just want to make sure that we can hide the color guess if this is true. If the submit guess Boolean is true. Really easy to do. You'll see that on the color guess parameter here, we have this visible if thing. And in here, we can write a little bit of script that will just hide it. We can make it only visible if certain things happen. So this is just a thing you have to remember. So it's input, square bracket, open quotation, and it's the identifier for the Boolean, which is submit guess. Right? So we go if input submit guess, close quotations, close square bracket. It is only visible if the submit guess button equals false. So if you hover over visible if or over the text field, it'll show you an example, right, of the format you need to use. So so you can see in the example it's giving, you can say like, hey, this float2 parameter, the y component of it, the second number, is greater than 0.3. Right? So you can do all sorts of fun stuff to hide and show different parameters. Like for instance, we could make it so that, let's just put this out for now. I'll republish the substance archive, we'll go into player. And now we have a situation where you can pick the color. And when I hit submit guess, I don't really need to get that. That's okay. That's decent. It's not close enough though. I can hit submit guess, and when I hit submit guess, the color picker goes away. Right? Now, the thing that's annoying, and I haven't been able to find a real workaround for this really, I think this is kind of just a limit, is this window stays open, so that color is still live. There's not really a great way to fix that, but this at least gets rid of some of the, now people can't go back and change their guess later once they start picking a different color. So I think it's good enough for now. I can't think of a good way of hiding that because I can't change whether that color, like that color picker should, what I would like is for it to go away the second you hit submit, but I can't program that. It's not really intended to do that. So can't fix that problem, but we can fix most of it. The other thing we could do is have it so that the submit guess button isn't visible until you've picked some sort of color. Right? Because right now what can happen is someone can go to submit guess and like just get some score and they're like, okay, well now what, right? So I would like this button to only be visible once a color has been picked. So how do we do that? We'll hop into Designer again, into the graph. And what we can do is, actually, we saw kind of an example of it earlier, right? When we hovered over the visible if, it shows you an example like, hey, you can say if a certain component of a float, in this case, the example is like the y component, is greater than a certain number, then make the data visible. So we could look at the submit guess button and say, hey, you should only be visible if either the x or the y or the z component of this is something bigger than 1, which means someone has actually picked a color. So in the visible if, we can say, hey, input close open bracket quotations color underscore guess, right? Again, that's the name, the identifier of the target parameter there. Close quotations, close brackets, dot x. So that's the red channel of that color is greater than greater than 0.01. Right, so we can save that and republish it. And if we do this, now we can see that the submit color button is not visible until we have some sort of value in red. Really should make it greater than 0. Right, because I had to put it up a little too high there. So we'll make the value here just greater than 0. Like that. Control S, I'm saving that. That's just a habit I'm in the habit of in case something crashes. So now this won't show up until there's like something in the red channel, right? And the submit guess button shows up. Now, the problem is it doesn't show up if there's anything in green and blue. And having it be a rule that submit guess button only shows up if there's something in the red channel is kind of broken. Because what happens if this is the color they want to aim for? Like if they are like, I don't think there's red in that color, they want this to be at 0, they can't submit it. Tough luck, right? So we need to give them the option to be able to say, hey, this will be visible if there is something in any of the channels. And we don't want to do if they're visible in all of the channels. It's if they're visible in any of them. So we're not looking for an and here, we're looking for an or. So it's the 2 straight bracket there is or. So we're going to say if color input X is over 0, that's fine. Or if input open bracket, open quotation, color guess, close quotation, close bracket, dot Y is over than 0, or over 0, right? Or input open bracket, open quotation, color guess, close quotation, close bracket, dot Z, right, which is the blue channel, is greater than 0. So now we have a nice system here where they can raise the value in, or they should be able to. Oops. Alpha shouldn't have been there. Oh, I did Z instead of, you know, X, Y, Z is fine. Yeah, I was right. My brain got scrambled there a little bit. If I raise these up in any channel now, it's visible. I had a bit of a brain destroyer there. Now the submit guess button is visible, even if we have just a little bit of color in either. Cool. Here. Sweet. So there, now we have it working. I must have like turned the alpha to 0, which hid the color. Yeah. So there we go. Now we're able to have this, the game flow works a lot better right now. Right now, they can try to pick their color, right? Hit their submit once they've entered a color, and then it'll hide the color, and they get their score. Pretty cool. I think what we should do now is very quickly set like a game over screen and a congratulations screen, right? So to know if you've passed or not. And again, in the Patreon video, we're going to expand on these. We're going to have different stars for how well you did, different colors to the score screen depending on how well you did. We're also going to have different difficulty modes, as you saw in the intro video, right? Like how we're going to have different modes that make it much harder to guess the color. Again, if you want that in the Patreon, or if you want that full thing, you can head over to the Patreon. And I'll be posting all of that in like the big long tutorial where we add all that stuff because it's just a lot more stuff. And I didn't want this. We're already probably at like an hour and a half or something, and I don't want this to be just this huge giant thing. And stuff will come out a bit later. So this is fine, but let's build that kind of fail screen. And we basically want to set like, what's the design of this, right? Do we want it so that there's a certain score threshold at which point you fail? And so for me, what I did was say, hey, if you get under 80%, you fail. So we can build that fairly easily too. What we'll do, so we'll call this section like UI. Cool. And what we're going to do now is build a death screen. And I thought it would be fun to make kind of the like the classic Dark Souls. It's like Princep or something. I forget the name of the font. It is called Princep or something. I'd have to find the name of it. Again, we can pick whatever we want for now. But there's a font in here that's awfully close to the actual You Died, like the classic You Died font. In fact, let me just see. Let's see. Optimus Princeps is the one we're looking for. So let's write You Died. You died. I need to go back. I need to finish the Elden Ring DLC. I still haven't finished the final boss. So it is Optimus Princeps. There, yes. That brings back a lot of trauma for sure. So here's our death screen. And we'll go, let's make this black and we'll do the classic. But if we're doing the font, we may as well make it like the whole classic. Yes. Although I think their red, if I had to guess, is like a little darker actually. I don't think it's like fully, I don't remember being that bright. It's just something like this. Okay. And I think we should show the score when people die. Unbelievable sentence. We should show the score as well, just so that people know like, I was so close, right? Like you don't want them to be like, well, was I close or not? Like, I don't know how good I did, right? So we'll add the score as well. So we'll blend together the score output and the text for score. Like this. And we'll add that to our mask. So at least people know how they did. And we might, and like I did in the full version, we're going to give them some instructions for how to try again. So reset and reseed. Go again. And same thing, I'm just going to blend this on. Scale that down, put it over here. Cool. So there's our death screen. Now we need to come up with the conditions with which this will show up. So I'm going to make a pixel processor here. You do this with a blend too, but we're going to do it with a pixel processor just so we get more practice in on them. And what we're going to do here is sample these entire textures and display them depending on what the score is. So we'll go to edit function and we'll go get float 2. Right now we want to sample both the color inputs to this pixel processor. So input 0 and input 1. Now, unlike the previous times where we were just plugging in a float 2 that was like 0.5 to sample the middle pixel, we don't want to sample just a middle pixel, right? Like right now, if we grab the middle pixel of input 1, it's just grabbing this gray. And if we grab the middle pixel of input 2, it should just grab black. If I set input, yeah, right? We want to sample every pixel, not just one position on the texture, right? 0.5 is just grabbing the middle pixel. We want to grab the whole sheet. So we actually need a special float 2 there called position. And the way you do that is you use a get float 2, and you'll see on the dropdown, we haven't exposed any float 2s anywhere. So you'd think there wouldn't be anything in this dropdown, but there is. Anything with these dollar signs in front of them means they're a system variable. So these are just in all substance graphs. They're kind of just there by default. And we're looking for a POS, position. And this will actually sample the entire texture, every pixel that's plugged into the pixel processor, everything in that UV space. And you can manipulate that space and do all sorts of fun things with that, which is a topic of a video that's coming up, I think, sometime in mid-April, late April. We're going to make this cool kind of animated campfire, and we'll be doing a lot of manipulating the coordinate space, which will be really fun. So we'll do this or this. Do you get to see your thing, like how well you did, or do you see the you died screen, right? So we need to make the condition there. And what we're looking for is to make an if, right? Because we need to know, hey, if this, whatever this condition is, if it's true, you should see the normal screen. And if it's false, you should see the you died screen. And what this really, the condition is what's the score? So we have our score here. We need to have a way of plugging it into this pixel processor, and we can't plug that value, right, just into that input because it's looking for an image, not a value. But we can click on the pixel processor and go down to input value here and hit this little cheeky plus button. And that will add a new value input. And we can rename this. You don't have to. We could call it score. But the name is sort of irrelevant. It's just organizationally for you to keep track of things. Putting the name as anything isn't going to matter a tremendous amount. So I'm going to actually make a portal node. You've seen me do this in all the Patreon videos for sure. I just press Alt to make a portal node, and I'll call this final score. And that's just so that I can make another dot node out here and select final score. And that's just so I don't have a noodle stretching all the way across everything and making stuff hard to understand, right? So at some point, we're going to do a video on like graph organization, and that will be a big part of it. But this is just so that, you know, here I don't matter, or I don't matter. I do matter, I promise. Here I don't care about it because it's not really blocking anything, but I don't want that strand just crossing everything. It gets really hard to see. So there you go. And I'll be including this graph in the YouTube description, a link to it, so you can download it and poke through it. So I just want people to be able to have them be legible when they're trying to learn. So there we go. Now we can access this score inside of the pixel processor. And the way we do that is we go get float. And now it will be pickable on the get float because he's being inputted into here. And now we just need to set the condition here. So if the score is greater or equal to 80, then this will be true, right? If you hover over this, the greater or equal function returns true if the first entry is greater than the second entry, or if the entries are equal to each other. So if the first entry, which is whatever the player's score is greater or equal to 80, then this will be true. If it's less than, it'll be false. So if it's greater than 80, we should just see the normal scoreboard. If it's less than 80, we should see the you died screen. And then we just go to the if else and set that as our output. So I don't know what the score is right now. The score is lower than 41. So we're getting the failed screen right now, which is fine. There we go. We don't need the 3D view. So let's save this. And there's one problem we're going to need to fix still. Pull this up. The issue is we are perma-dead. We're perma-stuck. And that's just because, think about it, right? Technically, our score under the hood here is really low because we haven't picked a color yet. So, and we're not even allowed to see the color we should pick because it's being hidden by the death screen. So really, if we think about it, it's not enough to just have this be the condition. It's not just that score needs to be below 80 to show the your died screen, because right now it is below 80, and as a result, we're always dead, right? Permadeath. We need to make another condition also be true, and what that condition should be is whether someone has hit the submit guess button. Because right now they haven't even made a guess and they've already died. It's not their fault. So we have to make another condition, and it should be get Boolean, and we'll pick the submit guess button. And we want to make it so that if both of these things are true, then this will work. So we're looking for an and. Like this. So this and, it only returns true if both entries are true. So if we think about it, if they've submitted the guess, that would be true. And if their score is greater than 80, it would also be true. So both are true. So we would show the correct screen. Right now, let's see this. Republish that. Here we go. Let's pick our score. Still can't see our score, which is good. We don't want to cheat. We hit submit guess, and we passed. If we reset that, and if we want a different color, right, we can just hit the randomize to get a different color. Which is really cool. And I'm going to try to match. I'm going to like purposely brick this one. And I submit it. We're 78.5. So we still didn't fail here. And we should figure out why that is. So submit guess is true. So let's look in here. Oh, so we just forgot to set this as the final output. And I think this also will probably have an issue. Yeah, we still have it showing only the died screen. And the reason for that is because submit guess is false right now, right? Unless I accidentally left it on true. Nope, that's fine. So submit guess is false. So it's showing, I think we just need to rearrange the order of these. I just had these placed in the wrong order. Let's see this. Yeah, I think I just had them in the wrong order. Let's get it pretty close. Oh, so what we need to do is swap the greater or equal to less. Or we can just invert these. So I just grab those and hit X. There we go. There we go. Right, desaturate. There you go. Cool. So we passed there. If we reset this, and again, I'm going to purposely brick it, we fail. Cool. So that works pretty well. So that's kind of like a basic game flow. There's one other fun thing I think we should put in, and that's an anti-cheat. Because right now, people could go to the guess and just go to the color pick and pick this, right? Just go to their color picker, grab that, and get a perfect 100. So we kind of want to build a cheat for that, an anti-cheat. So what I'm going to do is go, hey, and we're going to do a little bit of a fudging thing here, but I think it's important that people can't like cheat that easily. Posting it in the Discord, I'd already seen some people kind of thinking about, oh, you can cheat. Like right away, they're like, what's stopping me from using the color picker? And I'm like, all right, yeah, that's a good point. So let's build a cheat. And what Basically, what we'll do the cheat is that if they get it 100% correct, I'm assuming you're using the color picker. So we're going to make another pixel processor here. And this one is going to be the color cheat detector. So we'll call this little frame here the game over screen. And we'll make another version here. We don't really need, oops, copy this whole chain. It's not letting me copy it. Let's see. There you go. For this, we don't really need the score. We just need a big piece of text that calls them a cheater. So we'll go here and we'll go, well, we probably want to keep the reseed and reset. So here's our cheat screen. We can make a big angry face. You can make whatever you want. Cheat. Cheater. Police. This man here. And so here we'll do the normal game flow or the cheating screen. And we have to make that cheat function. So what we'll do is say in the cheat function on this new pixel processor, we delete all this. We still need to sample input 1 or 0. Input 1 is our cheat sign. Input 0 is our normal sign, or normal screen. So to determine the cheat, we have to get a float and grab the score. So really, honestly, we could probably just duplicate this whole graph because this is very close to what we need. But if the score is equal to 100, then we assume they're cheating. Right? Like they got a perfect 100. Let's just make sure that we have everything plugged in. Let's go back to the main graph. We do. Everything's nice and tidy here. And we'll rename this folder just anti-cheat. Save that, republish it. Go to our player here. And I'll make it so that if you pick and go to submit, it understands you're cheating. And you'd have to reset it, right? You brick the game. We can no longer see the colors. We can't enter color guesses. You should have to reset. Something worth considering is that right now it is actually impossible for someone to get in 100, which you want that dopamine hit, being able to hit that perfect 100. But we can't have the score value be 100 because that will brick it, right? And make it think they're cheating, or it assumes they're cheating. So what we could do is kind of fudge that a little. We could go into the value render. Right now its value is just the input that it's getting. So what we could do is change the value it's getting. Oops. We need to make an input on a value processor, and we'll plug the value in. And what we're going to do is just kind of fudge this so that the displayed score is slightly different from the computerized score that's driving all of the parameters. So I'm going to get the input that's coming in, and I'm going to add 0.01. So the idea is if they use, imagine this is their score. If they use their color picker and they get 100, this will go to 101. Doesn't matter. They're never going to see the score because it brings up the cheating menu. Caught. Right? What we can do though is, let's say they get 99.9. That's close enough that I would call it 100. So what I'm going to do is just keep a constant add of 0.01 so that the 100 is still possible. But we never wanted to be able to display a score above 100. So what I'll do is make a clamp here and set a max. So the clamp just sets a maximum and minimum. and we'll set a max of 100 and a minimum of 0. And that way, even if they put in like a point, like a 99.9, but we should set this to 0.1, I guess. I think that's better. So even if they put in 99.9 to get that close, anything above 99.9, we add 0.1 to it, and then we clamp it. So even if they were like 99.95, we add 0.1 to it. It goes to 100.05, but then we clamp it back to 100. So in this way, we're able to render out a score of, I've got to plug in the score input, not that float. Now we've just made it so that it is possible for people to get a 100 on this, at least from a score standpoint, but it will still always trigger the anti-cheat, which I think is, it's impossible in Substance Designer here to really make it like perfect and watertight for every type of cheating, as we showed earlier, but we can at least deter it and try to get rid of all the edge cases while still giving people like the dopamine they need. All right, so there you go. That's setting up kind of the basic game flow. You have on screen the full version of the game, which we did on the Patreon. But that gets you through most of it. I think people could probably figure out how to do the hard modes and prestige modes you saw me do. There's not a lot different from what we did already in this video. It's just more of it with maybe a couple tiny little tricks. But this should definitely get you going. And it's, I really wanted to get some kind of really fun example for pixel processors and value processors in kind of a more practical way that's, at least interesting and like a bit more simple. So I think this is a really good opportunity for doing that. So I hope you learned a ton from it. These are not just for making games in Substance Designer. I use them all over the place. But because the places I use them are awfully very, very specific and not just kind of general, I thought this was a better general example. So I hope that's like an easier way of approaching it. And then in future videos, I'm sure we'll have lots of other opportunities to do those kind of niche tactical uses of those processors. But I think this will be a good step into it. If you like the video, I appreciate you liking the video, following if you haven't followed already, turning on notifications, all that normal stuff. I'm going to put the link to download this substance graph we made today in the description so that you can just like download it and follow along with it, port through it if you'd like, as well as that value processor node so that you're able to use that in your graph to rebuild it. As well, if you're interested in the full video where we build, the total big, huge version here with all the difficulty modes and stuff, and you want to follow that tutorial along, it's quite long. But if you want to do that, that's on the Patreon. The link to the Patreon is in the descriptions. It's on the channel homepage, all that stuff. And over there, there's not just this, obviously. Also put on the Patreon the download to the full version, so you can download that full graph if you'd like. But there's a ton of stuff on there. There's a ton of tutorials that are really long. I think there's at least 3 or 4 now that are, like 7 hours. Like it's really a lot of stuff. And as well, just like early access to videos and all the kind of stuff you'd normally expect from Patreon, or if you just like to support me, which is also super appreciated. As well, there's a Discord access through the Patreon, and there's people, sharing stuff and kind of troubleshooting problems. And, I'm starting to see people post. It's now been enough time that people are posting in the Discord their versions of the materials from the tutorials, and that's been really cool to see. And people get really close. Like people get really, really good results out of them. Just following them along. It takes a while because they're so long. But I think the results speak for themselves. So if you're interested, I'd appreciate a follow over there. But for now, value processors, pixel processors, not as hard as you think, and we'll do way more in the future. So we'll see you guys in the next one.